Hey guys, good morning. Welcome to the Fundamentals of Aerospace Engineering lecture series. Today we are going to see the topic on the true airspeed. This is Professor Nehru, Department of Aerospace Engineering, SNS Government Technology. Last few classes we have seen about the different instrumentations and the measurements of airspeed. Now we are going to see the true airspeed, especially is the speed of an aircraft related to the air mass, which it is flying, not the airspeed. It is a true airspeed. Unlike the indicated airspeed, which is a speed shown on the airspeed indicator, true airspeed is a corrected for altitude and non-standard temperature variation. Here more about the true airspeed. True airspeed is the speed of aircraft relative to the mass in which it is flying. It is the actual speed at which the aircraft is moving throughout the air and is different from the indicated airspeed. So non-temperature things, we can see the true airspeed in this figure. True airspeed is the speed that airplane moves in the relation to the air mass it is flying through. If the air is perfectly still and the aircraft is flying straight and level, the true airspeed will be the same as ground speed. It means it is a corrected airspeed. So from seeing the in the indicator in last class we seen this the instrumental airspeed from the wind clamp condition and ground speed we will add it is 124 knots. So actual instrument airspeed it shows 110 knots, and whereas the true airspeed is 124 knots. The wind is to be corrected by doing the calculation. The calculation from the true airspeed is calculated by correcting the instrumental airspeed, altitude and the temperature effect. The altitude corrections account for the decrease in the air density with altitude, which results in a higher true airspeed at higher altitude. The temperature corrections around for the effect of temperature on the air density with the colder temperature leads to an air higher density and lower true airspeed. Mathematically, this can be written in the formula. True airspeed is equal to IAS into root of rho naught by rho. This is the TAS true airspeed is indicated airspeed when in terms of multiplication of the root of the ratio between sea level standard atmosphere density divided by actual air density at that altitude. So here the aircraft is flying in a different altitude, and that is not the same from the ground due to the temperature variation or the density variation. So this has to be remodified by doing the calculation and the formula. True airspeed is equal to indicated airspeed into multiplication of root of rho naught by rho. The correction done is two things. One is from altitude and temperature. Correction for altitude, true airspeed increases with altitude due to lower air density. It is calculated by correcting instrumental airspeed for decreasing in air density with altitude. Corrections for temperature, true airspeed decreases with colder temperature as air density increases. It is calculated by correcting instrumental airspeed for the effect of temperature on air density. The main importance of this instrument is to navigation and improve the performance of the aircraft. True airspeed used to navigation purpose as it is represented the true airspeed of the aircraft over the ground when wind causes effect are taken into the account. In performance, true airspeed is used to calculate fuel consumption, time en route, and range, as it is provided a more accurate measurement of the aircraft's actual speed through the air. So coming to the difference between true airspeed and the ground speed, wind effect and the wind correction angles to be noted. Wind effect, true airspeed does not account for wind, so to determine the actual speed over the ground, that is speed ground speed, the effect of wind must be added and separated from the true airspeed. Wind correction angle, Pilot use the difference between true airspeed and the ground airspeed to determine the wind connection, angle needed to maintain, and desired track over the ground. The difference between true airspeed and indicated airspeed, another thing is relationship. True airspeed is always higher than the instrumental airspeed at the same altitude, as true airspeed account for the decrease in the air density with altitude. Use in the flight planning, pilot use true airspeed in the flight planning to determine the expected ground speed and fuel consumption for a given true airspeed. In conclusion, true airspeed is a critical parameter in aviation, providing pilot with an accurate measurement of the aircraft speed relative to the surrounded air and mass. It is essential for navigation, performance calculation, and flight planning, which ensuring the safety and the efficient flight operation. Thank you.